Okay, today's lesson is chapter 3, section 6. This is the last one we're going to cover before your test, which it's technically 3.2 to 3.6, but so much of 3.2 is based on 3.1, I would basically say it goes back to the beginning of the chapter. So that would take us through like the special angles, the relationship between those angles if they're parallel, proving the lines parallel, the theorems about perpendicular lines, and then on Thursday, we did slopes of lines, and now we're going to talk about those lines inside the coordinate plane. So that's what today's section is all about. So there's technically on this slide two forms of the equation of a line, and they are point slope and slope intercept. So these are equations hopefully you've seen before, but you definitely need to have memorized. This point slope form is y minus y1 equals m times x minus x1, where the x1, y1 is a point and the m is a slope. Slope intercept, which is probably the one that most people know, is y equals mx plus b, and m is your slope and b is the y-intercept. And then there's these two special cases, which are vertical lines and horizontal lines. The vertical lines only have one variable, and that variable is an x. It would be like x equals a number. And that number is going to be your x-intercept. This would be a vertical line straight through that point. And then the horizontal line is y equals. So a line that's in point slope form would look something like y minus 3 equals 2x plus 1, something like that. So what will be filled in is your point, which is your x1, y1, and the slope, which is your m. In slope intercept format, what gets filled in is the m and the b. So it would be something like y equals 3x plus 2. And then the vertical lines, you're going to be missing the y. It would just say something like x equals 3. And the horizontal lines, you'd be missing the x. It would something like y equals 3. Yeah. So these are intercepts. You will see the points written this way. So if it gives you a y-intercept, if it says the y-intercept is 3, what that really means is that that point 0.03 is part of your graph. And if it said you have an x-intercept of 3, then that really means that 3, 0 is a point that's on your graph. So the y-intercept has a 0 in the place of the x, and an x-intercept has a 0 in the place of the y. It's always the opposite. So this one says, write the equation of each line in the given form. And A says a line with slope 6 through point 3, negative 4, and it wants it in point slope form. So the first thing you have to know is what point slope form is, which is y minus y1 equals m times x minus x1. And then the second thing is decipher the information that you're given. So if it says slope is 6, what letter does 6 represent? M, good. And if the point is 3, negative 4, that is my x1, y1, and just plug it in. So y minus a negative 4 becomes plus 4 equals the m, which is 6, times x minus a 3. And it looks just like this. So this is point slope form. You don't even have to distribute it. You could leave it just the way it is.
The last one was
This one says write the equation again of each line in the given form, and this time it says the line through negative 1, 0 and 1, 2 in slope intercept form.
y equals mx plus b.
That's my slope intercept form. Good. Y equals mx plus b. And for this, I need what two pieces of information?
Slope.
The slope and the y-intercept. Do I have either of those? No. So the first thing I have to do is find that slope. How do I find slope if I'm given 2 points?
y2 minus y1 and x2 minus y1.
Good. y2 minus y1 over x2 minus x1. So the x1, y1, x2, y2 would be 2 minus 0 over 1 minus a negative 1, which becomes 1 plus 1. And I get 2 over 2, which is 1. Now I've got the slope, which is one of the pieces of information. What kind of intercept is it if I'm given a 0 for the y?
It's under, no.
No, what kind of intercept? Is it x-intercept or y-intercept?
Intercept.
That's an x-intercept. That doesn't help me, right? So if that was 0, -1, then I already know the b. The b would be -1. But because this is a x-intercept, it's still not enough information. So there's actually 2 ways to do this. I'll show you both ways, and you get to pick which one makes sense to you. The first is taking this m, and then one of these points, let's say I take that first one, and plugging it into this equation, solving for b, and then plugging the m and the b back in. So that would look like this. The y would be 0, the m would be 1, the x is -1, and I don't know the b. And I'd get 0 equals -1 plus b, add the 1, and b is 1. Now I have my m and my b. So if I plug that into y equals mx plus b, it would be y equals m, which is 1, x, which is x, b, which is 1, or y equals x plus 1.
So you would plug in the.
So if you can plug in either point and the m and solve for b. That's one option, but that's in a slope-intercept form.
Why would the y be 0?
Because I took that first point, which is -1, 0.
Oh.
So that's one way to do it. The other way is using point slope format. So for that one, I would plug into y minus y1 equals m times x minus x1. And I'm plugging in one of the points. Again, I'll pick the first one just because it's easy. And the slope. So y minus y1, which is 0.
You can choose any here.
Yep, you can choose either point. Equals m, which is 1, and then x stays x, and x1 is a -1. Minus a -1 becomes +1. So I end up with y equals 1 times x and 1 times 1, which is x plus 1. So the difference with the methods is that the first one I have to solve for b and then take and plug it back in. The second method, if you use point slope, then all you have to do is plug it in and solve for y. But they will both get you the right answer. It's just up to you which one you feel the most comfortable with. Salvador.
But if you use, like, let's say for the first example, and you use the other coordinate.
Still get the same here. I'll even work it out. Ready? So let's say we picked this one instead. So it was y equals mx plus b. The y is now 2. The m is still 1. The x is 1 plus b. 2 equals 1 plus b. Subtract that 1. And b is still 1. And then I would plug back in the m, which is 1, and the b, which is 1. And I end up with the same equation.
Why would you use the 2 the second time instead of -1 like the first time?
Because I'm using this point now. So if you're switching and using this point, does that make sense?
Alright.
You can pick either point. Sophia.
Okay, so you put it in, so in order to solve it, you put it in point slope form, right?
That's this part.
And then you put it in slope intercept.
So if you put it in point slope form, all you have to do is solve it for y, and it puts it into slope intercept form. The other way is I plugged it into slope intercept form, which is this stuff. I plugged it into slope intercept form to solve for b, and then I had to take the b and the m and plug it back into slope intercept format.
So if you do it that way, then you have to do like the opposite of what you're doing in order to get it.
The one on the right, you mean?
Yeah.
Yeah, so the one on the right, you just plug it in once and solve, and you're done. The one on the left, you're plugging it in twice. The first time to get the b, and the second time to get your answer in the right format. All right, this time it says the line with the x-intercept 3 and the y-intercept -3, and it wants it in point slope form. So I still need the same two things in point slope form. I need a point, and I need the slope. If you decipher the way this is written, we said the x-intercept is when which letter is 0? The y, always the opposite. So the x-intercept is really 3, 0. The y would be 0, the x is 3. And the y-intercept is when what letter is 0? So this would be 0, -3. So this is similar to the last one in that I have 2 points, right? It's just that they're both intercepts. But I'm still missing what? Slope, which means I still have to do y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. I'll make these my 1s and these my 2s, although it doesn't matter. And I would get -3 minus 0 over 0 minus 3. And I end up with -3 over -3, which is a positive 1. There's my slope. Now my goal is to plug it into point slope format. And again, it doesn't matter which point you take, which means your format might actually look different from somebody else's, but it's still right. Let's pick the first one. Y minus y1 equals m times x minus x1. And I'd get y minus 0 equals my slope, which is 1, x minus x1, which is 3. You can either leave it like this or rewrite it without the 0. It's still point slope format. You don't want to distribute though because you want it to stay in that format. Braylon.
Would it be easier to y, like, instead of y minus 0, if you did y minus...
Plus 3.
Yeah, like
That's fine. So the other answer here is y plus 3 equals 1 parentheses x minus 0. They are both correct because you can pick either answer. And if you simplified both equations and put them in a slope-intercept, they would both be the same. All right, this one says a line with slope of 0 through 4, 6 in slope-intercept form. There's an extra E in there. God bless you. All right, so again, pay attention to what form it wants it in. It wants it in slope-intercept form. And pay attention to what kind of information you're given. So what am I given? The slope is 0, so that means m is 0. And I'm given a point. So this is where I've got 2 options. Either plug that in to the y equals mx plus b to solve for b, and then take it, plug it back in, or plug it into point slope. My advice is if you're given a point and the slope, plug it into point slope, and then just solve for y. So this is my x1, this is my y1. Y minus 6 equals, my slope is 0, x minus 4. And then I need to solve this for y because slope-intercept format is y equals mx plus b. So I get y minus 6 equals 0 times x is what?
0.
And 0 times -4 is?
0.
0. So then all I have to do is add the 6. Now think about what this means. What kind of a line has slope of 0? Nope. 0 would be what kind of a line? A horizontal line, right? Does that make sense? Yes? And if it's horizontal, then it's a y equals a number equation. So this should make sense. This is a good question. If there's 2 special cases, if the slope is 0 or the slope is undefined. If the slope is 0, then if you know that that means that's a horizontal line, and a horizontal line is a y equals question, then you do y equals and you grab the y and you're done. If the slope said undefined, now it's a vertical line, and a vertical line is an x equals equation, and you'd grab the x, which is 4, and you're done. You just have to remember that 0 is the y equals, no slope or undefined slope is the x equals. But then, yeah, you can avoid the work. Sophia.
So if on the test or on the quiz it just says slope is 0, then we can just put y equals 6 and we don't have to work it out.
Exactly. And if it said slope is undefined, you can give me x equals 4 and you don't have to work it out.
Okay.
It's just if you're wrong, I can't give you partial credit. So make sure you're right.
Defined and what's the other one?
So this time it says point slope form, which means I need a point and I need a slope. I have a point, which means I'm missing the slope. So m equals, if this is my x1, y1, x2, y2, 2 minus 2 over 1 minus a negative 3, or 1 plus 3. And I get 0 over 4, which is what? 0. So if you go back to what we just said a couple of minutes ago, what do we know about this line?
Has no horizontal.
Not no slope, it's 0. The slope is 0, which is horizontal, right? Angel, good job. And that tells you that this is what kind of an equation?
Y.
A y equals equation. So you can plug it in with slope being 0 and one of those points, or you can skip straight to the y equals, and what y am I going to grab?
Y.
Does it matter? What do we notice about both y's? They're the same. So if you had accidentally said, okay, this is an x equals equation, and you go look at your x's and you see that they're different, hopefully a red flag goes off, okay? Because if that's the case, then it's not an x equals equation. It's a y. So if the y's don't change, it's going to be a y equals. And if the x's don't change, it's going to be an x equals.
So how did you know it was a line?
Because my slope is 0, which means the line is horizontal, and the horizontal is a y equals.
And the y's, when it's horizontal, the y's are
Correct.
the same?
The y is always the same. Think about what happens in a horizontal line, right? So in this line, which would look like this, my x values on all of these points are going to change, right? X changes as I move from left to right. Oh my goodness, there's severe lag. But what you'll notice about the y's is they never change. So if you had written it as y minus 2 equals 0 times x plus 3, because that can also be point slope format, the 0 is going to cancel out that whole right side. So you could have plugged it in that way. The 0 still cancels out the whole right side, and that 2 still gets added to the right side. So your two special cases, which are vertical and horizontal lines, are going to be x equals and y equals, no matter what format it asks for here.
Like that's it. Like the answer is y minus 2 equals 0. All of it. You just put that, or do you have?
No, you'll go to this step. So the zeros are going to cancel out.
So if you get zeros for any of the things.
Well, for the slope, really. Just the
You
slope.
have to like cancel it out.
Yeah.
If you don't, wrong.
Let me find out what we're graphing the lines, okay? So in order to graph, this is y equals mx plus b format, right? So there's two pieces of information I'm given here. The first is your m, which is 1/2. The second is your b, which is 1. Now we said if it's a y-intercept, what coordinate is 0? If it's a y-intercept, which coordinate is 0? X. So this is really 0.01, right? Do we agree upon that? Yeah. So now, whether I use the b on the y-intercept or I plot that point, it's the same point. So I go to my y-axis, because that's where a y-intercept would hit, and I plot 0, 1. That first point is from the y-intercept. And now I use the slope as my rise over run to find the remaining points. So if my rise is 1, I go up 1. My run is 2, I go to the right 2. Do it one more time so you can get a nice straight line, and then connect your points. So we start at the B. On the y-axis, and that's the most common mistake people make. It is not an x-intercept, it's a y-intercept. And then use your slope to get 2 additional points. And then just connect them to get your line. All right, this one is in what format? Point slope. So I have 2 options. Pull out the point and the slope from this, or solve it for y and use the information the same way we just did. So let's do it the first way and then I'll go back and do it the second way. So if I'm in point slope format, then the m would be -2, which is the same thing as -2/1 because I need rise and run. And the point is the opposite of this one, which is -4, and the opposite of this one, which is +3, because my initial equation is negative, which means I always change the sign. So from here, I would plot my point, -4, 3, and then use my slope, which is -1, 2, down 1 and to the right, or sorry, down 2 and to the right 1, down 2 and the right 1, and plot my not so straight line, but you get the point. Okay, so we said our other option is to take this equation and solve it for y, so that's in slope-intercept format. So if I do that, I distribute the -2 to both the x and the 4, which would be -8. And then I would add the 3 to the other side. And I get y equals -2x minus 5. Now I've got it in slope-intercept format, which some of you are more comfortable with, which is probably a good idea if you wanted to do it, to rewrite it that way. So the b is -5, which means it's down here. And the slope is -2/1, which is down 2 in the right one. And this time when I draw that line, it would be there. If you compare it to the last one, it should look the same. The points are different. And there's a shift on it because we went to the right instead of to the left. But if you were to extend either one of those lines, they are correct. So you, again, you get the choice. You get to choose which way makes sense to you. If you are better off putting this into slope-intercept format and then graphing it, or taking it out of point slope. It's totally up to you.
How did you get 2/1?
So the like -2 itself was your slope. Do you get that?
Mm-hmm.
And then any number without a number underneath is really over 1. And you need that for your run. So any whole number you want to put over 1 because it's not 0 on the bottom, otherwise it'd be undefined.
Then why did you put the 5 over 1?
Because the 5 is a point. It's just not the slope. The slope is what you need to be a ratio.
So how did you solve from y equals -2x minus 5?
How do I solve it?
And how did you solve it?
Oh, I just took this equation and whoopsie-daisy, and I solved it for y. So I distributed the -2 in and then added the 3.
No, I'm talking about the last part. I mean,
From here, this is your m and this is your b, right? Because it's y equals mx plus b. So the number attached to the x is your slope, and the number that's by itself is your b.
so you just left it as that?
Yep, that's all I need. To graph it, that's all I need. These are the best because they require almost no work. But if you have not memorized what a y equals is yet, this is where you could go wrong, right? If y equals -3, what kind of line is this? Horizontal, and it would pass through y equals -3. The other way to look at it is if you've forgotten if it's horizontal or vertical, think all of the y's are -3. So all of these points are part of my graph, which means it has to be horizontal. What's the slope of that line? 0. Good. All right, so for this one, it's in slope-intercept format. The slope is 2, which is the same thing as 2/1, and the b or the y-intercept is -3. So I would start where y equals -3, which is down here. And then use my slope, which is a +2 over a +1, which is up 2 and to the right 1. And then draw your line. Raise your hand if you got it right. Okay, good. All right, second one, and again, remember we have 2 options, so I'll show you the first way and then go back to the second way. So the first one is if this is in point slope, that this is my slope. And my point is the opposite of this, which is -2, and the opposite of this, which is 0. Not 0, sorry, +1. And then I would graph that point, -2, +1, and then my slope, which is down 2 and to the right 3. Right, but when you take it out of the equation, you always change the sign because the initial sign was negative. So, it's okay. But again, if that confuses you, then go the other route, which is solve this for y. This time there's a fraction in here, which is not as much fun. Y minus 1 equals negative 2/3. This gets distributed to both. X minus and negative 2/3 times 2 over 1 is negative 4/3. And then add the 1, and I get y equals negative 2/3 x. Negative 4/3 plus 1 becomes 3 over 3, so they both have the same denominator. And this is a minus 1/3. So when I graph this, negative 1/3 is going to be approximately right there. I don't expect you to measure the line and find 1/3 of it. And then your slope is negative 2 over 3. So I'd go down 2 and to the right 3. I'm going to do it again, down 2 and to the right 3. Okay, last part of the section and the last part of the material that's on your test is systems of linear equations. So we talked about a systems of linear equation. This is two equations with two variables, okay? In this case, we're talking about two lines. So a system of linear equations in two variables represents two lines. If I had a y equals 2x plus 3 and a y equals negative 1/4 x minus 1, these are each individual lines. And there are three different kinds of relationships these lines can have. They can either be parallel, intersecting, or coinciding, which means the same line. So we talked about how you would figure out if two lines were parallel last week. Can you remember how? What would we know about their slopes? They'd be the same. So if the slope is the same, but the y-intercept is different, then they're parallel. If the slope is the same and the y-intercept is the same, then they're the same line, which would be coinciding. And then if they are neither of those, they are intersecting. So here's an example of what those would look like. The parallel lines, again, would have the same slope, but different y-intercepts. So these are the same, but these are not. Intersecting are going to have different slopes, and coinciding will be the same. So this last example 7 says determine whether the lines are parallel, intersect, and that should be an S, or coincide. So when you look at the two, you can look first at the slopes of the lines. So A is 3x plus 7 and negative 3x plus 4. These slopes are different, which already rules out parallel and coinciding, which means that these two would intersect. B, this one's solved for y, but this one's not. So the first thing you have to do is divide each of these by 6. And I'd get y equals negative 2/6, which is negative 1/3. And then 12 divided by 6, which is a positive 2. Now I want to look at their slopes. This is a positive 1/3. This is a negative 1/3, which means they are different. They could not be parallel or coinciding, and these are intersecting. And the last one, neither of them are solved for y, so I have to go through that work first. I would say add the 4x here. 2y equals 4x plus 16, and then divide by 2. And y equals 2x plus 8. That's the first one. This one is in point slope format, so I want to distribute the 2 and add the 10. This time, the slopes are the same, which means they're either parallel or coinciding, and for that, I look at the B. Because the slopes are the same and the B is the same, these are coinciding. If the slopes were the same, but the y-intercept was different, these would be parallel. Okay, example 8 says Erica is trying to decide between two car rental plans. For how many miles will the plans cost the same? So the first thing we have to do is come up with an equation for each of these. So an initial fee means that's a set fee that they're paying right off the bat. So it's 100 plus a mileage fee is a per mileage. So if we say miles are X, then this would be a 0.35X. And then the cost is equal to Y. For the second function, the set fee is $85, and it's 50 cents per mile, which would be 0.5X, and the cost is your Y. So the question is, for how many miles will these plans cost the same? So I want to know when these two are equal. So I can say that 100 plus 0.35X needs to equal 85 plus 0.5X. So I'm going to set those equal to each other. And then solve this for X. So I would subtract the 0.35X. I get 100 equals 85. This would be 50 minus 35, which is a positive 0.15X. And then subtract the 85, and I get 15 equals 0.15X. Divide both sides by 0.15. So I'd get 15 divided by 0.15. I have to move this decimal twice, which means move this decimal twice. So it's 1,500 divided by 15, which is 1. And then 2 additional zeros. So at 100 miles, these two costs would be the same.